In this video, we'll talk about the application of Internet of Things technologies in industrial automation. The trend in the industrial environment is to create systems intelligence by a large population of intelligent small network embodied devices at a higher level of granularity, as opposed to a traditional approach of focusing on intelligence of your larger and monolithic applications. So basically, when we see the keywords here, devices, that means actually shows that, well, it is the time to use Internet of Things technologies. So with this in mind, so people are developing a so-called service-oriented architecture paradigm to act as a unifying technology that spans several layers. So from sensors and actuators used for monitoring and control at software level up to enterprise and engineering system, as well as their processes as shown in the figure. So let's see the figure here. Basically, what people are, so for this SOA-based integration, so we have the higher level systems. So enterprise systems, for example, the ERP, the planning systems, and also the engineering systems, for example, the CAD, CAM software, and also quality control management system. So these are at higher level. And for the lower level, we have the devices. We have the different input-output interfaces. We have the gateway, we have the service moderator. And basically, by using the IP network on the wired and wireless communication method, so basically all these items can communicate with each other. So if you are in the electrical field, if you are in the electrical or computer science field, you will notice this actually looks like a bus line, right? So what it shows here is that by using the wired and wireless communication technologies, all these entities for these high levels and the low levels, they can communicate with each other. So for here we pay attention that for the sensors, actuators, sometimes they cannot communicate using the IP network directly. In that case, they need to use the gateway and service mediator. And we'll talk about these two items later. But the key point here is that we see for this SOA-based integration, it is very flat. It is not like this level is dependent on this level and this level. Basically, by using a bus, the IP network based communication here, all these entities, all these items can communicate with each other. So for the Internet protocol-based technologies, so there are many, basically there are the web technologies and protocols. They constitute a promising approach for integration, including the factory of future. So basically the IP technologies are the enablers here. So we mentioned, because for IP, you may have some idea. So if you go to the browser, and sometimes when you look at some movies, so they are trying to detect the IP address of a criminal or someone like that, right? Basically, IP is the address that can help you to locate and identify a device. Yeah, locate and device. And for the web technologies, so nowadays when you go to the browser and you type in a website, web page URL, for example, you type in google.com or youtube.com, then you will be directed to the Google or the YouTube. In that case, the idea here is that for the website you see, for the website you can see, for example, the YouTube, basically those videos, they are the services, and they are provided to you using the web. So do you follow me? Later on, we talk about the web services. Basically, that's something you can access in the format of a website. For those kind of services, for example, you go to the YouTube, so the service provided to you are mainly the videos, right? And if you go to the Google, And the services provided to you are mainly the search. And also if you go to the Twitter, so the services provided to you are the social communication. So all these are accessed using the format of a web. So that's the web service. And that's the IoT, and also the IoT, and as well as the SOA-based device paradigm. They make use of this web technology because it's relatively mature nowadays. Because the Internet of Things, the Internet has been there for many years, and web services are actually one of the mature technologies there. So as we mentioned earlier, Internet are using the Internet as a kind of a backbone, right? So web services, in this case, will definitely be used in the Internet of Things. And for services, basically, when we talk about services, basically they are the functions, as we mentioned earlier. So, and they are provided in the format of a web. And with this in mind, we should be aware that everywhere vision is not expected to realize overnight. So it will take a considerable time depending on the life cycle process and the different industries. Some industries, they are more willing to accept new paradigm, new technologies, they may move faster. Hence, it's important that migration capabilities are provided. So the idea here is the gateway and service mediator, as shown in this figure. So just now we mentioned that we would like to use the IP-based. We would like to use the IP-based technologies because by using IP, it's just like your home, like a physical address, right? For example, if you just type in address in the Google, for example, then it can direct you to the location. And the IP is actually the address on the internet. So if you just type in an IP, so it will direct you to the entity, to the service on the other end. That's why for the future of the SOA paradigm, we hope that we use IP for every devices, every system there, so that they can properly find their locations and pass the information. But for now, we still need some migration methods to deal with the sensors and actuators because many of them may not be IP compatible. Basically, they cannot use the IP to directly to communicate with other systems. That's why we need the gateway and mediator. So, and for these sensors and devices, they can provide the service. Basically, by saying that, we mean that they cannot provide a web service. So for the sensor, it may detect the temperature, for example, but we cannot assess this temperature without the help of a gateway and or the mediator. So for the next picture, it shows how Windows 7 can discover dynamic heterogeneous that are SOA ready. So it's here, maybe a little bit small here, but if we use discover system, we can see the devices discovered nearby. So there are some robots, there are wireless sensors, something like that. There are two different approaches to integrate devices in via gateway and service mediator. So the usage of them are to basically integrate the data from some sensors or devices that does not provide the IP capability and does not provide the web services. So for the gateway, it is a device that controls a lower level non-service enabled device, each of which is both a gateway as a service enabled device. Basically, you can imagine a scenario. So you have many sensors to monitor the sensor in a large warehouse, but the sensors themselves cannot be exposed to the web or to other systems. In that case, they need to use a gateway. The gateway basically will take the temperature monitoring and then it will develop service, for example, temperature service, and this service can be accessed using the web service. So that's what a gateway does. In that case, so for example, you have an enterprise system. It can communicate with this gateway as a service, and the gateway actually will take care of the communication with the individual sensors. It appears that the enterprise system can access every single sensor here, but actually it is because the gateway exposes these sensors like as a service-enabled device. So the enterprise system cannot access the sensors directly. They send a way to package the data into a web service. So service mediator, it's in my opinion, is quite similar. So it is meant to aggregate various data sources, including databases and log files. The mediator component involved and now used to aggregate various devices, but also compute and process the data. Because for the service mediator, sometimes your laptop, your computer can also be the service mediator. So basically, it's a more advanced level of the gateway. So sometimes the gateway is just focused on exposing the non-service enabled devices, but for the service mediator, it may involve some calculation and computation there. So as we can see here, so with a mediator, we can take in the data using IoT technologies from different devices, and then it can expose, it can compile different services. For example, it can show the temperature, it can show the pressure, it can show the utilization. Those are different services. As we can see in the future, IoT infrastructures demonstrated by millions of devices with different capabilities and needs. We have to consider how these integrate with each other and enable the realization of innovation approaches. So in that case, we need increased integration and collaboration of various layers. So just as we showed just now, and we also need functionality-focused layers of integration instead of device-specific aspects and device agnostic. So with the SOA in mind, so we know that eligibility and flexibility are required for modern factories. So they require an ecosystem of systems where a large scale will take place. So usually, meshing out services have proven to be a key advantage in Internet of Things. So mesh means that the services are able to be combined or integrated. A visionary project is called, it's quite long, Socrates. So it emphasizes on the cross-layer collaboration. So actually, it proposed and realized the SOA-based integration. So SOA integration we show now was an abstract concept, but for this Socrates project, it put it into the reality and put in more specific scenarios. So we'll show the figure in this slide. So we focus on the cross-layer collaboration, and the Socrates integration architecture realized an infrastructure for service can be utilized to enhance IoT operations and interactions among IoT enterprise systems. So the Socrates integrated architecture is like this. So we have the device here, and then by using different protocols. So you see the Bluetooth, the Zigbee. Then we have the platform abstraction to process, to collect the data. And then going through the security, we can do the monitoring and inventory. We can do service life cycle management, and so it is getting more abstract, and it reaches the different enterprise level applications. For example, ERP is the enterprise resource planning, SCM is the supply chain management. CRM is the customer relationship management. So this, as you can feel, these are higher level applications, right? And these applications, these platforms, these systems will use the WS. WS is the web service. Remember that. So the functionalities are realized in the format of service, right? So most of the time, under the internet, it is the web service. So these high-level systems will use the web services access the data and functionality provided by the Internet of Things. So with that being said, one can discern that various levels such as the application interface, service management, device management. So those are the entities in this figure. So I will leave the detailed reading to you. And also platform abstraction, device and protocols. Basically, the Sagreda's integration architecture is a real-world implementation of the SOA integration paradigm. Once again, to realize discovery and integration in a P2P way, a local gateway service mediator is implemented. So in this prototype, it is called local discovery unit, but you know it's gateway and mediator. With this Sagrada integration architecture, it has been implemented in very specific areas. So, for example, it is used in integration between PLC, a robot gripper, and some support wireless sensor nodes. It is used for integrate event-based interaction between an RFID reader and a robotic arm, a wireless sensor. For these systems examples, they are currently at the proof of concept stage. So that's just to let you know. So on the other hand, it means that it is very promising if you move into this area. Okay, so in the Sagrada's project, Sagrada integration architecture, yeah, if we look at the figure here, okay, so this is IoT stuff, and these are the enterprise level systems, right? So it seems it is still limited to a company, to an enterprise. So it is still considered to be what? Local, kind of. So by extending this concept, as that the cloud technologies and concepts are getting popular nowadays, and also it has the potential to change significant parts of modern factories pertaining to devices, systems, and processes. So by extending the Sagredas, so there is a follow-up industrial-driven project called IMC. Yeah, let me just call it IMC for short. Okay, was implemented. Basically, the improvement is to include the cloud technology there. But for the IoT, by nature, it should include cloud, right? So considering rapid advances in hardware and software, as well as IT concepts, so visions were set and prototypes were demonstrated. So the result was in line with the vision of highly dynamic, flat, information-driven infrastructure. So it shows this. So you see that the different levels are put on services, are put into the cloud, and they can be accessed by different systems or different purposes. For example, by doing business or modeling, management, mobile app. So basically these services put to the cloud in the format of industrial cyber physical system, and they can be accessed by different by different higher level applications. So what it does here is to create a service cloud. It links many components, devices, systems, services of a wide variety of scales and performing the different functions. So in this class, we have many abbreviations. So I uploaded a table, I would say, a table of abbreviation on the Blackboard so that you can see what does these items mean. Yeah, sometimes I don't remember them either. Okay, with the service cloud, so people are moved. There is an increasing trend moving towards information information-driven interaction that goes beyond traditional hierarchical deployment and coexists with them, with the empowerment offered by modern service-oriented architecture. The functionality of each system can be offered as one of services of varying complexity, which may be hosted in the cloud and composed of each other, as we shown in the figure just now. Not this one. So it's shown here. So we have different stakeholders, and we have different higher level applications for data, for management, so on. And these are the functionalities. Usually they are in our context, they are exposed as services, right? So the idea here is what? The functionalities of each system can be offered as one or more services by varying complexity, which may be hosted in the cloud and composed by other services. This transition marks a paradigm shift towards a cross-layer and information-driven interaction. So next-generation industrial applications can now be rapidly composed by selecting and combining new information and capabilities offered to realize their goals. What it means is that the services are now, will be able to be combined into the specific requirements. For example, for the engineer, so this is the service cloud, okay? And the engineer, so what does the engineer need? So he or she may need the human-machine interface, and need the model, and maybe need the control, or maybe the technology integration. So by using the service cloud, the engineering can put these functions together into a specific combined service that works for him. So that's the idea of what we mentioned here. And as we mentioned, there are several user roles that will interact with the envisioned architecture, either directly or indirectly. So these are the different roles. With different people will need different services there, right? As we can see in that figure, it is possible to distinguish several service groups, for which there have been some initial services. So the services are to provide key enabling functionality to all stakeholders, as well as CPS populating the infrastructure. So this is an emerging cloud of things, have the potential to transform the way we design, deploy, and use applications and cyber-physical systems. So the idea, once again, the idea is that the services put onto the cloud and they're accessible to different stakeholders, and the stakeholders can synthesize and combine the services they want into a composite services that fit their need. And once again, just like when we talk about the e-maintenance, outsourcing key functionalities to the cloud is also challenging, and further research needs to be done towards applicability of several scenarios. So as we can see in this cloud, yes, some of these services may be outsourced. That means that by some specialists or by some dedicated service providers. So then this kind of outsourcing model, there may be new business models, and they still need further research. And to conclude, the prevalence and advanced embedded devices in conjunction with increased processing and communication capabilities is transforming industrial automation. So service-oriented architecture is now possible, and we are trending towards information-driven integration. We are moving into a fully dynamically customizable infrastructure. And of course, we have some challenges.